What's up everyone, it's Powell, and in this video I'm going to start a multi-part series on completing the square. Now completing the square is a skill that is very useful when it comes to quadratic equations. So we're going to go over a couple different topics on how to use completing the square. And the first topic is on changing the form of a quadratic. Now these three examples are given in what's called standard form, which is ax squared plus bx plus c. And I want to change them all to vertex form, simply because vertex form is just a little bit easier to graph. And I say easier because it takes less time, and I like things that take less time. So I'm also going to go over the way I like to complete the square, so some of these steps might seem a little tedious, but this is just how I do it to organize my progression on completing the square. So if you get really comfortable with these steps, you can always skip a couple as you go. So the first example is y equals x squared minus 6x plus 11. My first step is to just move the plus 11 over. Now if you don't know what completing the square is, essentially it is adding a number to this to make a trinomial that's able to be written as x plus something squared. So I'm adding some number that will allow that to be factored as x plus something squared. So I'm completing the square. That's essentially where it comes from. And what do I add, you ask? Since this is in standard form with an a, b, and a c term, I'm going to add b over 2, or half of 2, squared. And for this example, our b is negative 6, so half of negative 6 is negative 3, and negative 3 squared is 9. But I can't just add a 9. I have to keep the right side of this equation balanced. So if I add a 9 to balance it out, I subtract a 9 on the end. So all I really did was add 0. But I now have a trinomial, x squared minus 6x plus 9, which I can now write as x minus 3 squared. It's always going to be x minus half of b squared. I'll write that here. So this is always going to be x minus half of b squared. And you already know what half of b is because you had to square it to get the number you added in the end. And the only other thing you'll have to do is take the 11, subtract 9 from it, and I get plus 2. So these two equations are the same equation, they're just in different forms, and they're graphed much differently. And I know from that bottom equation that the vertex is 3, 2. Whereas in the first equation, I'd have to find the axis of symmetry, plug it in, evaluate. Again, not difficult, just less work. I like less work. So now let's skip on over to the next example, which is a little different because you might notice there's a coefficient in front of the x squared. This makes it a little different, but I'll show you what to do. So if I look at the first two terms, again, I want to isolate these two terms, so I'm going to move the plus 1 over. This step is a little bit gratuitous, but I'm going to do it anyway, just because it's habit. And what I want to do is I want to get that leading coefficient factored out from those first two terms. Again, I'm not going to touch that third term yet. I'm going to leave that be. I'm going to factor out a 3, and I get x squared minus 4x, leave a space, and then the plus 1 on the end. And nothing happens with the 1. So as before, inside the parentheses, I'm going to add half of b squared. Half of negative 4 is negative 2, and that squared is plus 4. But I'm not going to subtract a 4 in the end because I added a 4, but I added a 4 inside of a grouping that's being multiplied by 3. So I didn't add a 4, I added a 12. So in the end, I have to subtract 12. Mainly because 12 is 4 times 3. It's a little weird when that happens. And I'll do, in the following videos, I'll always include an example where this happens because it's very strange. But as before, I have a trinomial that can be factored. So y equals 3, and this is x plus half of b squared. And then 1 minus 12 is negative 11. So again, I have the vertex form of the quadratic equation I started with. and I know the vertex is 2, negative 11. So not too bad. This last one though is a little strange because my leading coefficient is negative 1. Nothing else changes, but you're going to see why this is a little bit of a strange example. So as before, I'm going to take negative x squared minus 14x and move over the negative 47. And from the first two terms, I'm going to factor out that leading coefficient of negative 1, and I get x squared plus 14x minus 47. Again, the 47 stays negative. And I take half of 14, which is 7, squared to get 49. I added 49 inside the group, but if you take into account the leading coefficient that I factored out, I actually added a negative 47. So since I added a negative 49, since I added a negative 49, I have to add a positive 49. That's why it's a little weird, because I added 49 inside the grouping. That grouping is being multiplied by negative 1, so I actually added a negative 49. So I have to add a positive 49 on the end to balance it out. So it's just strange because I wrote positive 49 twice. As before, this grouping gets factored into x plus b over 2 squared, or x plus 7 squared, and then I just add the two numbers on the end, and I get positive 2. So I have the same equation, but in a different form from what I started with. So those are 3 examples of completing the square. One where it's pretty straightforward, one where it gets a little more complicated, and one where it gets equally as complicated, but with the negative it's just weird. So I hope you liked my video. If you did, please subscribe and comment below on any topics you want me to cover in the future. And thanks for watching.